Hey everyone, Mr. Herc here, and today I'm going to be going over the 2.9 to 2.13 quiz. I'm hoping that by making this video, you can learn your mistakes before your next test. And so there's two versions to the exam that if you took it in class, you will have one of these two, version A and version B. To know what version you have, simply just look at what questions match up. If you look at the next slide and you see that the questions don't match the numbers or the actual questions itself, then just skip ahead to version B and watch the video from there. These questions are going to be pretty much the same. There's not many differences between them besides the number changes, but I'm going to be going over both versions just in case. If you did not take the exam in class, you will have a version C. For obvious reasons, I am not going to release those or go over the answers publicly. But after you take the test, if you want to know what you missed, come see me in office hours Monday or Tuesday before your test on Wednesday or Tuesday if you're B day, and we can go over it together. All right, so for version A, question number 1, the function h is given by log base 49x, and then where do we want to see what x value yields an output value of 1/2. So remember, if we have this, a log form, and we want to solve for x, we're going to throw this into exponential. So remember, when you have log base a c equals b, in exponential, it's a to the power of b equals c, which means in this case, it should be 49 to the power of 1/2 equals x. 49 to the 1/2 is just a square root of 49, which is 7. So 7 should be our answer, D here. For number 2, we're going to split this up by, remember, when we have two things multiplied, which is 4 times e to the third, we're going to split that up into the addition or sum of two logarithms. So let's do that now. And then when we have something in the denominator, we are going to split that with a subtraction. So we're going to subtract ln square root x. Continuing this, we know that the square root is x to the 1/2. So let's rewrite that there. And now let's move any exponent out in front. So here, this is ln of 4 plus, and actually let's simplify this first. We can cancel out the ln and the e to just get 3 by itself, and then minus 1/2 ln x. And so this should match up with answer choice A, making A the correct answer for number 2. For number 3, the function g is given by log base 2x. Which of the following could be the graph of the inverse? So here we know from the notes that the inverse should be 2 to the power of x. Taking a look, that's an exponential function, so we can eliminate a and d. Those obviously don't match. Looking at this, the difference between b and c is c runs through the point 1, 3, while b runs through the point 1, 2. And we need to see which one is 2 to the power of x. And so obviously when we plug in 1, 2 to the first is 2. That should be our x value, making b the correct answer there. All right. Number 4, the logarithmic function L is defined by L of x equals 8 ln x. Which of the following pairs of limit statements correctly describes the end behavior? So for this one, because our a value is positive, our general shape should look like this. That's always going to be the case when a is positive. And so here, obviously, as we approach positive infinity, right? So the limit as x approaches positive infinity for L of x, this is going to be going up forever, so this should be positive infinity. That means we can narrow it down to either A or C. And then the next one is we want to talk about this, the left tail. And so this is going to be the limit as x approaches not negative infinity, but 0 from the right-hand side of L of x. This approaches negative infinity because it goes down forever. And so A should be the correct answer there. For number 5, which of the following could be the equation? Here we saw with this general shape, a is positive, and it's going to be a logarithmic function, making b the correct answer. If a was negative, it would look like this, is where a is negative there. Number 6, the function k is given by log base 3x. If g of x is the inverse, then what value of b does b equals 27? So here the inverse of k of x, or g of x, is going to just be 3 to the power of x. And then we want to know what value of b can we plug in here to get 27. So 3 to what power gets us 27? That should just be 3 for b. Number 7, the function f is defined by log base 7 of 100x, and we want to see this rewritten with a log base 10. So let's use the change of base and rewrite this as log base 10, 100x, over log base 10 of 7. Now that we have that, we're going to split it up into addition in the numerator. So this is going to be log base 10, 100, plus log base 10 of x over log base 10, 7. And now we know log base 10 of 100 is just the number 2. So this really just becomes 2 plus log base 10x over log base 10, 7. And this should correlate with answer choice B. Just be aware you will see this question reappear on the test next week. Number 8, the function g is given by log base 5x. Which of the following statements about the inverse is true? Well, we know the inverse is going to be with the same base, so 5 to the power of x, and then we can eliminate it to b or c. But what is the domain? When is it defined? And remember, any exponential is defined for all real numbers, so C is the correct answer. But you could also get this by taking log base 5x. If we find the domain and range, and then you find the inverse there, remember the domain becomes the range, and the range becomes the domain for the inverse. So for a log function, x has to be greater than 0. That's going to become the range. That's unfortunately not what our question is asking, but for our range for a log function here, because one side goes up forever and one side goes down forever, this is going to be y is equal to all real numbers. So all real numbers should also be the domain for the exponential, making C the correct answer there. All right, number 9. The table shows values of a function f at selected values of x. Which of the following claims and explanations are true or best fit the data? So here we want to see what type of function this is. And so we see times 2, times 2, times 2, and so on. And then here we see plus 2, plus 2, plus 2, plus 2. And so we see a multiplication rule up top and then an addition rule on the bottom. That's always going to be a logarithmic function. So we can cross off any of the ones that say exponential. And then with the logarithmic function, right, the input values change proportionately. That's true. As the output values increase in equal length intervals. That's also true, making C the correct answer. D's wrong because the output values don't change proportionately, right? These are outputs, and they change at a constant rate, or with an addition rule rather than a multiplication rule. Number 10, let g of x equal log base 7 x plus 4. Which of the following gives the domain? Remember, domain is only going to be impacted by horizontal translations, like that. And so typically it would be from 0 to infinity. That's a regular domain for a log function. However, when we shift this 4 units left, we're going to take the domain and also shift it 4 units left to be -4 to infinity. So any dilation or vertical translation will not impact the domain, simply just horizontal translation. All right, now let's solve some of these. These were where a lot of people missed points, either by not simplifying enough, not knowing how to factor, mistaking their properties. So these are going to be important because you'll see 5 of these reappear on your test. So here we're going to get I'm going to rewrite this as log base 4, and then this is not 8, but it is 4 squared. So I'm going to move any coefficient into the exponent. like this. This should then turn into log base 4, and then here we're going to get 4 squared, or 16. I'm just going to write that as 16, x to the 7th up top, and then x to the 5th. A lot of people stopped there. However, you would be expected to simplify this into 16x squared, and then over 1, which is just itself. So that's our answer for part A. Part B, 2 to the power of 3x times 2 to the 4th, and this is to the power of x plus 1, all over 2 cubed. Now remember, the mistake I saw a lot of people make is they don't distribute out that 4. So this should be 2 to the power of 4x, not plus 1, but plus 4 over 2 cubed, and then 2 to the power of 7x plus 4 over 2 cubed, and then this is 2 to the power of 7x plus 4 minus 3 is just plus 1, and that should be our answer for part A. All right, so for part B, we want to set this whole equation equal to 2, and then we want to solve. So I'm going to start by simplifying the left side to turn this into log base 3, and not 2x minus 8. A lot of people wanted to add the insides, but no, you actually multiply them. So you should get x squared minus 8x, and then this is equal to 2. The next mistake I saw was a lot of people wanted to say x squared minus 8x equals 2 and just set it equal to each other. You can't, because it's not log base 3, 2, it's just the number 2. So with only one log, what you want to do is convert this from logarithmic form to exponential. 3 squared equals all the inside, so x squared minus 8x. This is 9. And then subtract 9 from both sides. Once we get here, we want to factor. So I'm going to factor that into x minus 9, x plus 1, and get our two solutions of x equals 9 and x equals negative 1. Unfortunately, though, when we plug negative 1 in here, we would get log base 3 of negative 1, and you can't take the log of 0 or a negative number, so x equals 9 should be our only solution. The next one here, we're going to set 14 equal to 5 plus e to the power of 7x. Here we want to isolate this exponential part of the equation, so we're going to subtract 5 from both sides. 9 equals e to the 7x, and then take this and convert it into logarithmic. So log base e to the power of 7x equals 9, and then I'm just going to rewrite this as ln 9 equals 7x, and then divide both sides by x to get ln 9 over 7 equals x, and that should be your answer for part B. Part C, this is going to be the A method. So remember, 6 to the power of 2x is the same as 6 to the power of x squared when we break up the multiplication of the exponents. So let's rewrite this as 6 to the power of x squared minus 6 times 6 to the power of x. And because these do not have the same exponent, you cannot multiply them to get just 36 to the power of x. A lot of students tried to do that, but you can't do that in math. And then we want to see where this equals 16. And so now it should be pretty clear that we want to use the A method. So this should be a squared minus 6a minus 16 equals 0. We want to solve this quadratic. So this should be a minus 8, a plus 2 equals 0, a equals 8, a equals negative 2 equals 0. And now sub it back in. So 6 to the power of x equals 8, 6 to the power of x equals negative 2. And then working on these, we should get this to be log base 6 of 8 equals x when we convert that to exponential form. And for the next one, we would get log base 6 of negative 2 equals x. And this would also be no solution because you cannot take the log of a negative number. So that is it for version A. Here I'm going to run through version B. kind of starting from scratch. So if you hear explanations again and you like keep watching from version A, that's why. All right, question number 1. The function f is defined by log base 5 100x. We want to see what is the equivalent representation using a log base 10. This is going to be a change of base. So here, using the change of base formula, we should get log base 10 100x over log base 10 5. And then splitting this up, because it's multiplication, I'm going to rewrite that as log base 10 100 plus log base 10x over log base 10 5. This then should be log base 10 100 is just the number 2 plus log base 10x over log base 10 5. And this should correlate with option B. Taking a look at number 2, the function g is given by log base 4x. Which of the following statements about the inverse is true? Well, we know now the inverse should be if it's logarithmic exponential with the same base, 4 to the power of x. And then, what is the domain for this function? Well, if you know it's exponential, the domain should be all real numbers, so C should be the right answer. But let's think about it this way, right? If g of x equals a log function, log, let's say, base 4x, and then we have the inverse, which is 4 to the power of x, the domain and range for the log is going to be the domain is x is greater than 0, right? Because you can't have the log of a negative number. And the range is going to be y is all real numbers. So that is going to flip for the inverse for the exponential. So the domain here is all real numbers, and the range is y is greater than 0. So that's why when we were asked, the range should be all real numbers, or making C, again, the correct answer. All right, number 3, the table shows values for a function f at selected values of x. Which of the following claim and explanation is correct? So taking a look here, we see a multiplication rule up top, right? Times 2, times 2, times 2, times 2. There was a mistake, so I did manually have to adjust that. And then we saw an addition rule on the bottom, plus 2, plus 2, plus 2, plus 2. And so what this means is this is going to be a logarithmic graph when you see a multiplication rule up top and then a addition rule on the bottom. So we can eliminate A and B. And then for C, the input values change proportionately. That's true. And the output values increase in equal length intervals. That's also true. Here, the output values change proportionately. That's not true. They change at a constant rate or increase in equal length intervals. So that's why D is wrong, making C the correct answer there. All right, for number 4, here we have a log function. Which of the following gives the domain? For this function here, whenever there's a horizontal translation, that will be the only thing that you can have with a graph that will affect the domain of the graph. For example, if a typical graph would have a domain of 0 to infinity, but when you have log base 5, x plus 3, you move it 3 to the left, so the domain should now turn into negative 3 to infinity, making B the correct answer. For number 5, here we are given that this is log base 4x, and we want to know where does this yield an output value, or y value of 1/2. Converting this to exponential so we can solve for x, we should get 4 to the 1/2 is equal to x, which is the square root of 4, which is just 2. So 2 is equal to x, so D is the correct answer. And then for number 6, splitting up this multiplication, we're going to turn this into ln 5 plus ln e squared minus, so remember because this is on the bottom, we're going to do minus ln and then the square root of x. Knowing this as well, we can do 2 simplifications. The first thing we can do is cancel out the ln and the e to just get 2 here. And then we're going to do minus ln of x to the 1/2. And now I'm just going to move that 1/2 out front to get ln 5 plus 2 minus 1/2 ln x, and this correlates with option choice A, making A the correct answer. Number 7, here we're given g of x is log base 3x. What is going to be the equation of the inverse? Here we know the inverse is 3 to the power of x, and so it's going to be exponential, so we can eliminate A and D. And then B or C, which one's correct, and what's honestly even the difference between the two? B runs through the points 1, 2, while C runs through the point 1, 3. And so when we're looking for 3 to the power of x, C is our correct answer, because when we plug in 1 for x here, we're going to get 3 as an output. So C is the correct answer for number 7. Number 8, the logarithmic function is given by L of x equals 7 ln x. Which of the following statements describes the end behavior? When we have 7 ln x, here our A value is positive, so the graph should look like this. Knowing that, as we approach infinity, right, so the limit as x approaches infinity for L of x, this is going up forever, so this is going to positive infinity. So we can eliminate B and D just from there. And then how would we describe this left part of the graph? This is going to be the limit as x approaches not negative infinity, but 0 from the right-hand side, because it won't cross this vertical axis or asymptote of L of x. This is going to negative infinity. It's going down forever. And so that's going to be option choice A, where C is basically the correct answer, just a little jumbled up. All right, number 9, the graph of f is shown above. Which of the following could be the equation? This is the general graph when A here is positive. So we're just looking for a logarithmic because it doesn't pass the y-axis that has a positive A value. So A should be the answer here. And then number 10, the function k is given by k of x is log base 2x. If g of x is the inverse, which in this case, if we first want to find that out, that's just 2 to the power of x. For what value of b does g of b equal 8? So solving this, 2 cubed is obviously 8, so b is going to be my answer there. All right, now let's work through the short answer questions. This is where a lot of people miss points, either because they did not simplify enough, they made a mistake in their work, or they added the insides together when they should have multiplied, just little things like this. So being able to clean this up before the test is important because you'll see 5 more of these questions on next week. So here we should rewrite this as moving 3 and 5 to the exponents. So this is going to be log base 3 and then 3 cubed, not 9, but remember 3 cubed is equal to 27. This is then going to be plus log base 3 x to the 5th minus log base 3 x to the 4th. This then should then simplify into 27, and we should get log base 3, 27, and then x to the 5th over x to the 4th would be like that, which we can simplify into log base 3, 27x, and that's going to be our answer there. For part 2, this is going to be rewriting it in 2 to the power of ax plus b. So converting everything to a base of 2, we should get 2 cubed and then x minus 1 over 2 to the 4th. Simplifying this, 2 to the power of 2x, and then remember to distribute that 3. Whoops. So this should be 2 to the power of 3x minus 3 over 2 to the power of 4. This is 2 to the power of 5x minus 3 minus 4. So we should get 2 to the power of 5x minus 7 as our answer there. For part B, here we are going to set the two equal to each other. So log base 2, and then I'm going to combine them by, remember, we're not going to get 2x plus 6, but we're going to multiply them to get x squared plus 6x equals 4. And now a lot of people don't know what to do here, But here you actually just want to convert it from logarithmic form to exponential when there's only one log in the expression to like simplify. Once we have this, this should be then 2 to the fourth equals x squared plus 6x. This is 16. And then we are going to subtract from both sides and then factor. X plus 8, x minus 2 looks about right. We should then get x equals negative 8 and x equals positive 2. And so x equals positive 2 should be our solution there. So that is going to be our answer. Looking at B2, this is going to be 4 plus e to the 6x equals 11. Here we're going to subtract 4, so e to the 6x equals 7, and then take this and convert it into logarithmic form. So log base e of 7 equals 6x. This is then just going to be ln 7, and then divide both sides by x to get just ln 7 all over 6 is equal to x, and that should be our answer for B2. All right, and then finally we have C. This is going to be an A method. So remember, 5 to the power of 2x, when we break up the multiplication, should be 5 to the power of x squared. So let's rewrite this as that, 5 to the power of x squared minus 5 times 5 to the x equals 14. Here we'll sub in A is 5 to the power of x to get a squared minus 5a minus 14 equals 0. Factoring this, you should get x minus 7, x plus 2. So x equals 7, x equals negative 2 there. Solving both ones simultaneously. So here you should get, 5 to the power of x equals 7. And then for this one, you should get 5 to the power of x equals negative 2. Solving this, the first one, you should get log base 5 of 7 when you convert it from exponential to logarithmic. That is true, so that's the first check mark. This one here, we should get log base 5 of negative 2 equals x. And remember, you can't have negative on the inside or anything related because negatives in the logs give you domain errors. So here, log base 5, 7 is going to be our only solution to part C. Hopefully that should help. If you have any other questions, please come see me in office hours, and I will see you guys later. Thanks.